Hello guys, so just wanted to record some homework videos for you this week. That way you have some references to just look at and make sure that you are going in the right directions. So the first homework that we're looking at is the types of symmetry homework. That's the one that has the 4 questions walking you through whether or not it's symmetrical over the theta equals pi over 2 or the polar axis or the pole. So with that, let's just jump in. I have a couple examples that are just very similar to the homeworks that we're going to do. So for number 1, I have 7 plus 2 sine of theta. Okay, so we are going to start by testing if it is symmetrical with theta equals pi over 2. So remember, to do that, we have 2 options. We can either replace it with negative r negative theta, or we can replace it with r pi minus theta, either one. So let's try and start with the first one and see what happens. Remember, you want to test both of them if they don't work. Like if one doesn't work, you want to make sure you test the second one. But as long as you get one of them to work, you're done. You know that's a good answer. Okay, so I've got 7. Nope, hold on. I forgot to put r equals up here. There we go. So we're going to replace it, make it negative r equals 7 plus 2 sine negative theta. So I'm going to go ahead and work through this then. So negative r is going to stay negative r. 7 plus, and we know that actually I'm going to get rid of that plus sign because, remember, sine of negative theta is the same thing as negative sine of theta because it's an odd function. So I'm going to have minus 2 sine of theta. Basically just taking that negative and moving it out. Remember, you can do that with sine and tangent, but with cosine, the negative doesn't move out, it just disappears. So then I can go ahead and divide by this negative over here. We get r equals negative 7 plus 2 sine of theta, and I compare now. Does that look the same as that? Nope, because that 7 is negative and it wasn't negative. So I'd say no, this does not have symmetry over the theta equals pi over 2 axis. Okay, so let's try this other one then. Let's see if this other one will do it for us. So r pi minus theta. So I keep my r the same. 7 plus 2 sine of pi minus theta. So again, here we're going to use our sum and difference formula. So remember, with sine, the way sine works is you do sine and cosine of the first and second one, and then you do cosine sine of the first and second one, and keep your sign the exact same. So I'd end up with r equals 7 plus, we'll put our 2 outside, and then put a bracket here. You always want to take whatever's in front of the sine of the cosine. You always want to just stick that on the outside. That way it's something we'll save for the end. And then I can go ahead and do this difference formula. So sine of pi times the cosine of theta. And then since it's a minus sign here, we're going to use a minus sign as well. And we're going to put cosine of pi sine of theta. Perfect. And I'll just go ahead and work through that. So I want to think about the coordinates at pi. So in my unit circle, pi is over here. And that's going to be the coordinate negative 1, 0. That got real ugly. I'm sorry. 1, 0. There we go. So I know the cosine is negative 1 and the sine is 0. So I can change this sine of pi to 0. I can change this to a negative 1. And then just think about what's going to happen there. So 0 times cosine, well, 0 times anything is 0, so I'm going to end up with 0. Over here I've got this negative 1 times sine of theta, which is going to become negative sine of theta. But because it's minus negative sine of theta, this becomes plus sine of theta. Why did I put an r here? Too early. Need more coffee. R equals 7 plus, and now I can go ahead and simplify. 0 plus sine of theta is just sine of theta, but when I distribute that 2, I get 2 sine of theta. And would you look at that? Those two things are the same, so then I can say, well, yes, it actually does have symmetry to the to theta equals pi over 2. But that's why you have to make sure you test both, because you can see right here is one of those instances where the first one didn't work, but the second one does work. So you have to make sure that you're testing both so you can see that. All right, so now that we know that we have our theta equals pi over 2, let's go ahead and try the next set. Okay, so now I want to test if it has symmetry to the polar axis. Remember, to do the polar axis, what we're going to do is either replace it with r negative theta, or we can replace it with negative r pi minus theta. Either option. So let's start by doing r negative theta. So I'm going to make this r stay r, 7 plus 2 sine of negative theta. Well, I know what's going to happen here. My negative is going to move out, so I end up with 7 minus 2 sine of theta, and that is not the same. So as of right now, it is a no. Coming over here, let's try the other one. Negative r equals 7 plus 2 sine of pi minus theta. So again, we'll do our difference formula here. So I end up with 7 plus 2 on the outside, sine of pi, cosine of theta, minus cosine of pi, sine of theta. And these are the same numbers as last time, so we know what happens here. We know that sine of pi is 0. We know that that cosine of pi is negative 1. And then when I work that out, 7 plus 2, this first part's going to become 0. And then I've got minus a negative sine of theta, so it becomes plus sine of theta. Again, because this becomes negative 1, negative 1 becomes positive 1, and we have positive 1 sine of theta. So ultimately here then, we know that this 2 could then distribute in here, right? We'd have negative r equals 7 plus 2, drop to 0 at this point, we don't need it. So it looks almost the same, but this little negative right here is going to screw everything up now. Because when I divide by the negative to move it to the other side, it becomes negative 7 minus 2 sine of theta. And that's not the same. So this would be a no. It is not symmetrical with respect to the polar axis. One last one to verify then. And that will be verifying if it's symmetrical over the pole. So if it's symmetrical over the pole, okay, I was just going to leave that, and now it made me angry, so we're not going to do that. It just bothered me. Okay, so if it's symmetrical over the pole, then we should be able to replace r with negative r and have our theta, and we should be able to replace the other way would be r and replace it with pi plus theta. So let's go ahead and try that. So negative r equals sine plus 2 sine of theta. Obviously, we know that's not going to be right. Exactly. Right. When I divide by that r, I'm going to get negative 7 minus 2 sine of theta, and that's not the same. So nope, done. Right away, we can see that the first one's not going to work. So the second one says we leave the r the same, and then we replace the theta with pi plus theta. So we're going to have 2 sine pi plus theta. So I'm going to use my sum formula there. So 7 plus 2 on the outside, and I get sine of pi cosine of theta. I don't know why I put a comma there. Plus cosine of pi sine of theta. Again, these are the exact same numbers, so I still know that this is 0 and this is negative 1. Like, that's not going to change. R equals 7 plus 2. So I have 0 on the front. This time, though, because it's a positive and then negative 1, right? Negative 1 times sine of theta is going to be negative sine of theta. But that positive is not going to cause the sign to change. So it's going to be minus sine of theta. So we end up with r equals 7 plus 2. Hold on, not even that, right? Because this is going to simplify to negative sine of theta. And then when I distribute that 2, it's going to become minus 2 sine of theta. So this right here, not the same as our starting one, right? It shouldn't be a negative 2. It should be a positive 2. So also no, this is not a valid one. So it looks like this only has symmetry with respects to theta equals pi over 2. And that would be the only pole we have to look at and we have to worry about. So let's take a second example look. So another one that I think is worth looking at is something that's similar to number 2. So number 2, I think I wrote this down. I said let's try looking at r equals 4 minus 9 cosine of 4 theta. It's kind of a bigger one. That's a little bit more intimidating, right? But we're just going to work through it like we would normally. So the first thing we're going to check is theta equals pi over 2, and see what happens here. So again, we know that to do that we have to replace either both with a negative, or we can replace just pi minus theta. So trying the first one, negative r equals 4 minus 9 cosine of negative 4 theta. Right, so if there's a 4 theta or a 2 theta or a 3 theta, you just put the negative in front of the number in front, because theta, negative theta times 4 is negative 4 theta, so it's the same thing. And then we just apply our rules here, right? So we have this negative r, 4 minus 9. Well, cosine is an even function, so because this is negative in there, it doesn't change anything. It just stays the same. Cosine of 4 theta. We just drop the negative. It's just cosine and secant are the only ones that you could do that. Just drop the negative, it's inside. Where sine and tangent, and there's reciprocals, you have to pull it out. So then, well, I can see what happens here, right? You got this negative out front. You're going to distribute it, or sorry, divide it to the other side. So we have negative 4 plus 9 cosine of 4 theta. Well, that's the exact opposite of what we started with. So as of right now, I would say no, this does not have symmetry with respect to pi over 2. So let's try plugging in the difference side. So r stays the same, but this time cosine of 4, and I'm replacing theta. This time, though, we have to put the theta here. Pi minus theta. This one I think is going to be a little bit tougher to do, right? We're going to have to actually think about that 4 as its own piece that has to be distributed in, right? So if I rewrote this, it would be 4 minus 9 cosine of 4 pi minus 4 theta. That's the difference formula I'm working with there. So then when I go ahead and write out the entire thing, put our 9 on the outside still, we'd have cosine. Remember, cosine does cosine, cosine, and then the opposite sign, and then sine, sine. So what I mean by that is I'm going to do cosine of 4 pi and cosine of 4 theta. And then because this is minus, we're going to put a plus, and then we do sine of both of them. Sine of 4 pi and sine of 4 theta. So while this might seem a little bit intimidating at first, I think once you get to this step, it kind of starts making sense what's going to happen, right? You just have to think about the whole unit circle, but this time we're going around twice, right? 4 pi represents, if you went around the unit circle one time, you're at 2 pi, and then if you go a second time, you're at 4 pi. So essentially what we're looking at is this coordinate right here. And again, just to illustrate that a little bit more clear, here I am rotating. This is 1 pi, 2 pi, 3 pi, 4 pi. So it's going to be that coordinate there, which we know is the coordinate 1, 0. So I know that in here I can take out cosine of 4 pi, and cosine is going to be the first number, and I replace it with a 1. So I have 1 times cosine of 4 theta. Plus, and I know sine is going to be the second number, which is 0. So I take out the sine of 4 pi, replace it with 0, and I have 0 sine of 4 theta. And I know it's going to happen here. 0 times 4 sine of 4, 0 times anything, 0, right? So that 4 sine of theta, or sine 4 theta, goes away. So I'm left with r is equal to 4 minus 9, and then this piece right here, which is cosine of 4 theta. 4 minus 9 cosine of 4 theta, 4 minus 9 of cosine of 4 theta. Those are the exact same thing, so I'd say yes. This really actually does have symmetry with respects to the theta equals pi over 2. All right, so looking at the next one, cleared. Okay, let's go ahead now and confirm if this has symmetry over the polar axis. All right, so polar axis, we know that to do polar axis, we're going to replace, I totally still have to keep looking at this, r and negative theta, and then negative r and pi minus theta. So just know that those are tough. Like, there's not even something that I've memorized yet. As I keep doing them, I'm noticing I'm starting to pick up some patterns. Hopefully you'll do the same thing so they don't remain as tedious. Again, we're checking polar axis here, right? I meant to switch colors. I like using different colors. Okay, plugging in here. R equals 4 minus 9 of, we're going to replace the theta with the negative theta, so we have negative 4 theta. Work this out, 4 minus 9, and that negative inside just disappears, so it becomes cosine of 4 theta. Look at that. Yes, and we could stop right there then. This has symmetry with respect to the polar axis, and we're done. So at this point now, we've proven this one has symmetry with respects to theta equals pi over 2 and with respects to the polar axis. So we're on a roll here. So let us check one more. We just need to check if it has symmetry now with respects to the pole itself. So with checking the pole, what we're going to do is we're going to replace negative r and leave theta as is and see what happens. But we're also going to check if we replace leave r as is, but replace it with pi plus theta. So coming in here, then we're going to have negative r equals, and I already see exactly this one, no issue here, right? If I didn't change anything except making this r negative out front, unless this is r squared to make this negative go away, it's not going to. So I know that this is not going to work because I can't do anything to this problem to actually get rid of that negative again. So let's check the other side then. Leave r the same and plug in pi plus theta. So 9 cosine of 4 pi plus theta. All right, again, distribute that 4 in first. 4 pi plus 4 theta. You could just do that step right away at the beginning too. You don't necessarily have to write it out and distribute it. You could just know that if there's a number in front, you're going to put it on both the pi and the theta in those problems. So let's set up that sum formula then. 9. And then cosine, so we're going to do cosine of 4 pi, cosine of 4 theta, and then change the sign and do sine of 4 pi, sine of 4 theta. Well, again, we know this is going to give us 1 and this is going to give us 0. So ultimately this minus side doesn't even matter. It just matters what is in that first spot because we're minusing 0 from over there. So I have minus 9. Well, 1 times cosine of 4 theta is going to give us cosine of 4 theta. So I have 1 minus 9 cosine of 4 theta. Would you look at that? It's the exact same thing. So not only does this have respect to theta equals pi over 2 and the polar axis, but it also has respect to the pole. I almost said the origin. The pole. So 3 forms of symmetry there. So hopefully that helps you out with those types of questions. Those two kind of cover the main majority of them. So good luck. Let me know if you have any questions. Bye, y'all.